there is one file called extra in the Blackboard. Extra. I mean, not chapter 1 or 2 or whatever. Extra, I put some material for extra and I wanted to go back. I put some information about chapter 9. I think it's very beneficial. It's summarized the whole chapter for you. Extra. Go to the Blackboard, open the file which is called extra, not chapter 1 or 2 or 3. Go to chapter 9, which is extra. There is a file called extra, and you will find the same. The first thing in that thing is called chapter 9. Let me see. Yeah, I think it's called chapter 9 to 13. Exactly, it's called chapter 9 to 13 extra. I'm not sure 100%, but I think it's called.
Yes, doctor, I found it.
You found it? I think it's called chapter.
Yes, as you said, doctor.
9 to 13 extra.
Yes, that's
right. Okay.
Yes.
And chapter 9 for the whole chapter for you. I want you to look at it, and I will go over it very quickly. The first thing I told you to know these things, definitions. You must know what's this theory. What's this theory? You must memorize the name. Valence shell electron pair repulsion theory. You must know that. Good. Second, I want you also to know the electron domain. Electron domain, very important. And electron domain, we talked about it a lot, in which we have A is the central atom, B is the bond. It's not the terminal atom, it's the bond. Okay, and E is the electron pairs. Okay, and I want you also to know in this chapter we have what's called valence bond theory and the meaning of hybridization. Okay, then in the valence shell theory, they tell you that you have what's called the shape that we're going to have. This is, of course, linear. This is trigonal, planar. You must know this name very well and memorize it. What's this name? What's this?
Tetrahedral.
That's you must memorize tetrahedral. Oh, I should also go back to this one. The angle here, of course, is what?
180.
And this angle?
120.
There will be definitely one question in which they say, what's the angle between these things? And you should know it. This tetrahedral, what's this called? What's the angle?
109.5.
You must memorize the angle. Okay, what's this called? This shape?
Trigonal pyramidic.
Bipyramid. Trigonal bipyramid. What are the angles between this one and this one? What is it?
90 and 120.
The one which is in the plane.
120.
So we have two important angles, 90 and 120. Okay, and the last one is called what?
Octahedral.
Octahedral. And the angle is?
90.
Exactly 90 in all directions. All right. I gave you also in this shape here, you have the just a second. Okay, I also okay. Okay, this is the shape, very quickly, the shape of the tetrahedral. Can you see the shape? This is the shape of the tetrahedron, and that's the angle is, that's the angle. And then also I have this shape very quickly. And it is very slow, but you can see it in your
الو صوتي قطع دكتور.
هذا بس هذا شكل التتراهيدرال، هذا شكل التتراهيدرال موجود في هذا، ما حنتكلم عنه، بس هو موجود. طيب بعد كذا سيجنال باي بيراميد، للاسف تيوب تقطع، لو تشوفونها عندكم في البيت افضل.
ايه دكتور.
اوكي، هنا مره بطيء النت. سيجنال باي بيراميد زي ما انتم شايفين، الثلاثة الزرق على البلين والخضر هم متعامدين على البلين. الزاوية بين الزرق 120، والزاوية بين الأخضر والأزرق 90 degrees only. alright. وآخر شيء بالنسبة للأوكتاهيدرال، أوريكم مثال بسرعة إن شاء الله، موجودة عندكم زي ما قلت لكم في ومتعامدين بالضبط 90 degree على بعضهم البعض. هذا بس للعلم، على اساس ان شاء الله نستمر. طيب بسم الله. طيب هذا الجدول مهم جدا، هذا يختصر تقريبا شابتر 9 كله، ولازم تشوفون هذا الجدول وتحفظونه زين. على الالكترون دومين حطيت لكم انا كل الالكترون دومينز، هذه الالكترون دومينز، وكم مجموع n بلس m. طيب وهنا اعطيت لكم الشيب الموليكولر شيب، هذا اسمه الموليكولر شيب، فهذول اسمهم موليكولر شيب. في حين لو قلت لك الالكترون دومين شيب كل اذا كان الالكترون دومين نستخدم الاصلي اللي هو تراينجل للثلاثه، هذا وهذا الالكترون دومين شيب تراينجل. بس لما يكون في electrons, if we have electrons available, then the shape will be V shape or bent if there is electron. If there is, this is should be one. Whenever I don't write, and sometimes we don't write it, this is one. Okay, I want you to sit down, memorize all the electron domain, and these are the molecular shape, not the electron domain shape. The electron domain shape, you should take the original one, which is first one only, for as if there is without electrons. Okay, so all the four, what's the electron domain shape for these three things, 1, 2, and 3? What's the electron domain shape for AB4, AB3E1, and AB2E2? What's the electron domain shape?
Tetrahedral.
Tetrahedral. All of them is tetrahedral. The electron domain shape, but the molecular shape, this is called tetrahedral, this is called trigonal pyramid, this is called V shape or bent. I also gave you the angles. You must memorize the angles. And I told you which one is going to be non-polar and which one is going to be polar. I told you which compounds are polar and which compounds are not polar. All right. Also, I gave you here the hybridization by the valence bond theory, which we also talked about. If we have n plus m equal to 4, for example, what will be the hybridization? It will be always sp3, sp3. And I gave you example of this table, of this example. If you look carefully, very carefully at this table, you can almost summarize the full chapter 9. So sit down, study this shape, this table extremely well. Is this clear? واضح يا شباب?
Yes, doctor, but I have a question.
Yes, go ahead.
What's the difference between the molecular, could you please, and the shape? Could you please elaborate more?
What's the difference between what?
Yeah, النقطة اللي قلت عليها مهمة اللي هي الفرق بين الشيب والمولكيولر شيب.
Electron domain shape and molecular shape, which I write here, molecular shape. There is a difference. As I said, the electron domain are these shapes. This is the electron domain. So, for example, what's the shape of this molecule? Of this shape here? Tetrahedral.
Yes.
This shape is going to be for 3 examples. For example,
methane.
Methane, which is AB4E0, is going to be tetrahedral, electron domain. How about NH3?
Trigonal pyramid?
No, that's what I'm saying. The electron domain shape is tetrahedral.
But the molecular shape is different.
Shape, we cannot see that, because if you take the electron domain, you put the electrons there as one thing here, and so it should be tetrahedral. But since we cannot see the electrons in the shape, in the molecular shape, we will see the shape like this. N, H, H, H. And what will be the shape? It will be trigonal pyramid. trigonal pyramid. And you should know what's the angle. The angle here is, what's the angle here? 109.5.
Less than.
This one is less than 109.
Less than 1.
Clear? Now, let's talk about water. O, H, H, and 2 electrons here and here. This is A, B, 2, E2. What's the electron domain? What's the electron domain shape? Sorry. What's the electron domain shape?
Tetrahedral.
Also tetrahedral. The shape of the electron domain, which is this one that you're looking at, is tetrahedral, similar to this one. But again, we cannot see the electrons. So what are we going to see?
Bent.
V shape or bent, exactly. And what will be the angle in here?
Less than 120.
No, wrong.
109. Yes.
Yes, less than 109.5. That is for tetrahedral. It will be less than 20 for this shape. For this shape, if we have something like SOO, and this is the electron domain now, what's the shape of this electron domain? You should write AB2E. So what's the shape of the electron domain? The shape of the electron domain.
trigonal pyramid.
V shape.
No. Triangular planar. Planar. Or triangle. If you say triangle is enough. Triangle. مثلث. Okay, but again, this is the shape of electron domain. What's the shape of this molecule?
V shape.
Yes, it will be V shape. What's the angle?
Less than 120.
120.
120. That's important. See, this one is 120. The water is V shape, but the angle here is what? Less than 109.5. Is this clear? Is this
Yes, clear.
So as I said, you must sit down today, memorize this table extremely well. And I gave you example. Try to write this example and see how you apply. I gave you example of everything in this table.
دكتور.
Yes, طبعا.
مثلا في الاختبار يعني بتجيب مثلا CF4. طيب يعني أنا عرفت مثلا إن الإلكترون دومين AB4 بس يعني الاتجاهات راح تعطينا هي يعني عشان نعرف إذا هي نون بولر ولا بولر.
في الاختبار أعطيك مثلا أنت قلت SF4 بعطيك SF4 وبقول لك من الأسئلة اللي ممكن أسألك الآتي أو بقدر أسألك أقول لك إيش الإلكترون دومين شيب؟ إيش حتقول؟
تتراهيدرال.
خطأ.
إلكترون دومين شيب.
إيه.
4.
تريجونال باي بيراميد.
يس تريجونال باي بيراميد. لأنه إيش لازم تسوي؟ أول شيء you have to draw the shape of the molecule which is SF F F F and 2 electrons here. So the electron domain you must write it. It's A B 4 E1. If it's AB4 E1, what does that mean?
سيسا.
It is C. No, that's the molecular shape. If I ask you what's the electron domain shape, what's the answer?
تريجونال باي بيراميد.
Trigonal bipyramid, not trigonal pyramid. Trigonal bipyramid, that's the electron domain shape. I can ask you, I tell you, what's the molecular shape? What are you going to say?
seesaw.
Seesaw, that's the molecular shape. It's not the electron domain shape, it's the molecular shape. I can ask you, what are the important angles? I can ask you this question. What's the important angle? And you should tell me 120 and 90, not 1, but 2. Clear? I can ask you, what is the, is this molecule polar or non-polar?
Doctor, the 90 and 120, between what and what in this this molecular?
2 is less than 120, and between these two, it's 190. So there is 90 and 120.
Oh.
Less than and less than. Is this molecule polar or non-polar?
Polar.
You should know why it is polar and memorize it. I can ask you, what's the hybridization in this molecule? See how many questions I ask you about the same? That's why I think if you should memorize everything in this table and memorize it extremely, extremely, extremely well. Is this clear?
Yes, but doctor, sometimes like it's non-polar, but if you draw the dipole moment, it will change. It will be maybe polar.
No, you cannot. You cannot have that.
If they were in the same
If it's polar, it will be polar. Of course, this is polarity. If the terminal atoms are what? Important. Terminal atom must be what?
must cancel each other.
No. What's terminal atoms must be what?
Must be same.
The same. If you change the terminal atom, everything become polar.
Okay.
Is this clear?
Yes.
If you change the terminal atom, everything become polar. Yani, for example, if I just write here, this molecule belongs to what? A, B, 2, E0. All right? Okay. And AB2, E0 will go back to this table. AB2, E0, which is this one. This is AB2. This is E0. This means it is non-polar. Right? But if I have COS, then this is still the electron domain AB2 E0. But is this polar or non-polar?
Polar.
This is non-polar, the first one, and this one is polar. Why the second? Even though the electron domain is exactly the same, why this one is polar and this one is non-polar?
Because of terminal.
Because of terminal atoms. You must know this. So, as I said, I repeat and I will continue repeating that you must memorize this table extremely, extremely, extremely well. Is this clear?
Doctor?
Yes.
So we should memorize these elements, or it's just an example?
No, these examples, you don't memorize it. Know how to do it, how to write you must know how to draw Lewis structure for all these molecules. Draw Lewis structure. Don't forget this. That's important. And this is in chapter 8. And all of these, you must be able to draw the Lewis structure for them very well. And this way you review chapter 8 also. And then apply all these rules for them. As I said, this table is extremely, sit down, don't just read it like this. Like, for example, if you go to anyone like this one, let's take now, for example, it's okay. IF5, for example, IF5. If I can ask you many questions. If I ask you, what's the shape of this molecule? What's the very first thing you must do?
find the electron domain.
Lewis structure first. You must draw Lewis structure, which we took where? In chapter 8. And I will do it like this. Okay, then I can ask you, write the electron domain for it. What's the electron domain? I need help.
AB5.
AB5,
AB5,
One.
E1. Exactly. What is the shape of the electron domain?
Octahedral.
Octahedral. That's important. What's the shape of the molecule?
Square pyramid.
Square pyramid. See, the first thing you must do is draw the right Lewis structure and then answer my question. See, I already asked you 3 questions. The electron domain, the electron domain shape, and the square pyramid. These are 3 questions. Any one of them can come. 4th question, is this polar or non-polar?
Polar.
Polar. It must be polar. Why? Because it belongs to this one. Okay. Next, what's the more important angle? What's the angle of this shape, the whole shape?
less than 90.
Less than 90. It's not less than 109.5 or less than 120. No, all of this. And so, see, I already gave you 5 questions for the same molecule. And any of them can come, by the way. And for the exam, I can ask you if you have IF5, for example, or I can give you anything else. If I give you, for example, I can give you SF4 minus. SF5 minus. Yeah, SF5 minus. That's something else. SF5 minus, that's another molecule now. This molecule exactly like IF5. And that's why if I ask you anything about SF5 minus, you should give me the same answers. Is this clear? Do you have any question?
Doctor, how is XEF2 non-polar?
إيش؟
Is it because of straight line? XEF2.
XEF2. XEF2 is non-polar. Of course, what is XE? Oh, okay. Yeah, it is. What's the shape of the molecule? Do you know?
Straight, it says.
Yeah, of course, because it is XE, F, and then we have 3 electrons domain like this. What is and they always, if you have trigonal bipyramid, the electrons will go to the base, not to the terminal atoms. Okay, what's the electron domain for this molecule?
AB2, E3.
AB2, E3. Very good. Next, what's the electron domain shape?
Straight.
Electron domain shape, no, wrong.
Trigonal bipyramid.
Yes, trigonal bipyramid. Electron domain shape. This is electron domain shape. Now, what is the molecular shape?
Straight.
This is straight. I agree with this. And the last question is this polar or non-polar?
Non-polar.
Non-polar. Non-polar. And the last also what's the angle between XF and FXEF? What's the angle?
180.
Exactly 180. Not approximately. Why? Because electrons are from all sides. And that's why it is exactly 180. See, I also ask you 5 questions for this exam.
Doctor,
Yes.
if we replace one of the F,
Yes.
maybe we put like I, iodine.
Yes.
It will be polar.
Come on. We said this many, many times. You mean this molecule?
Yes,
You answer me. Is it going to be polar or non-polar?
polar.
Why?
Because non-polar, I mean.
No, it is polar. Wrong. It is polar. But why?
Because
Huh?
because different atom will be, dipole moment will be like more.
Yeah, they will be different. That's why whenever you change the terminal atoms, these are called terminal atoms, and this is called, what's the name of one?
Central.
Central. And these are
Terminal.
terminal. If the terminal atoms in this molecule, if this terminal atoms are the same, then it will be non-polar. If you change the atoms, in any molecule, if the terminal atoms are not the same, then this is automatically polar. You don't have to think. Clear?
Yes, yes.
Okay, good. I hope this table is extremely fully understand, and you must memorize everything in it. Oh, I have another question here. What's the hybridization in this molecule? In XCF2, what's the hybridization?
sp3d2.
No, sp3d1,
2.
not 2. sp3d1. You must also know this. What's the hybridization in CO2?
SP.
Sp. What's the hybridization of SCO?
SP, same.
Also Sp. What's the hybridization of FXEI, this molecule?
SP3D.
sp3d1. All right, you must know what's the hybridization in this molecule. What's the hybridization in H3?
sp3.
sp3. You must memorize this and know it extremely well. You should know, not memorize, but know why it is sp3, why it's sp3d1. We talked about this before. Okay, as I said, everything in this table is extremely important. Good. I also discussed in chapter 9 how to make sigma and pi bond. The first bond in here is what? Sigma.
Head to head.
Head to head or end to end. Head to head or end to end. You must memorize both names. Head to head or end to end. And one of the questions I can ask you, why or when are we going to consider a sigma bond? And you should tell me whenever we have end to end or head to head. And the multiple choice, I can put either end to end or head to head, and you should be able to know, is this bond sigma or pi?
Sigma.
Sigma between S and P. Okay, how about this between P and P? What type of bond is this?
Sigma.
What? Also sigma between this P and P.
Pi.
Pi bond. You should know when are you going to have pi bond and sigma bond. All right, is this is also clear. And then I draw here for you the valence bond theory, how the bond take place. How the bond take place. Okay, the carbon will bond to the hydrogen and the other hydrogen, and the pi bond is something like this. This is the extra p orbital which is available in the, you remember each carbon in this molecule, like CH4, C, H, 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 H. Now, what's the hybridization of I'll call this one carbon 1 and carbon 2. What's the hybridization of carbon 1? Hybridization.
sp2.
sp2. Of course, I told you that, again, back to the table. How do you know the hybridization? You should know that if you have 2, you should calculate n plus m. So you write the electron domain and calculate n plus m. If it's 2, automatically it will be sp2. If it's 3, it will be sp2. If it's 3 and 3, sp2, sp2. If it's 4, what is it going to be? sp3. If it's 5, it will be sp3d. And if it's 6, it will be sp3d2. You should know this relation automatically. Here, in this carbon, what's the electron domain for carbon 1? AB2E what? Oh, sorry, AB3.
Not AB3.
AB3, I'm sorry. AB3E
0.
0.
Zero.
What's the total? What's the total B, N plus M?
3.
3. So what's the hybridization?
sp2.
It is 3. Anything with 3, it must be sp2, sp2. Good. Now, what's the electron domain for the second carbon, carbon 2?
It's the same. AB3E0.
AB3E0. AB3E0. What's the hybridization?
sp2.
sp2. Can you draw the electrons that will be hybridized? There will be 3 boxes for this carbon, and of course, and 1 box will be empty. What's the name of the first 3 boxes?
sp2.
sp2. Each one of them is called sp2, and the box by itself.
Or B.
P, only P. And the same thing for the other carbon. I'm not going to draw it. Then, what's the valence of carbon? 4 electrons. 1, 2, 3, and 4. Okay, the second carbon, same thing. You have 3 boxes and 1 box by itself. What's the name of the first 3 boxes?
sp2.
sp2. Each one of them is called sp2. Okay, so this one is sp2, 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 and the last one is called what? P. Okay, now this one has also 4 electrons, 1, 2, 3, and 4. Now we should know that this electron here, oh sorry, first the other electron will come. We have in these boxes, the hydrogen will give us 1 electron here when it makes the bond. This hydrogen will give us one electron here, and then this box with this box, now this one with this one will interact to make the sigma bond. So this electron here is going to be here coming from the other carbon, and it will be shared. So it will be in this carbon and in this carbon from each other. Each one as if they are sharing these 2 electrons. These 2 electrons that I'm drawing here are the electron which is making this bond. And this one is making CH bond, and this one is also CH bond. Same thing here. This hydrogen will give electron here, and this hydrogen will give electron here to make this a CH bond, and this is CH bond, and this one that I'm writing here is CC bond. Okay, then the P will interact with the P to make what type of bond?
Bi.
The bi bond. This one, this electron and this electron are what's available in this orbital, and this orbital, they will mix together to make the bi bond, which is the second bond in here, which is here. I hope this is also clear. Okay, good. That's the shape also for the same molecule, another drawing to see how the bond take place. See, it's very clear here. sp2 will interact with sp2 from the carbon. The sp2 will interact with the hydrogen. The sp2 will interact with the other hydrogen. This sp2 will interact with hydrogen. This sp2 will interact with hydrogen. And this one, these 2 will interact to make the bi bond. That's a very clear drawing that you must look at and be careful how to make the bonds. That's called valence bond theory. And the most important word here is hybridization. What's the meaning of hybridization?
Mixing.
Mixing, don't forget this. Mixing, sp2 hybridization.
Doctor, always p
What?
orbitals. Always p orbitals make bi bond.
If it's free, if it's empty. Yeah, I mean, if there is a 1 electron in it, yes. Only the p bond, p orbital will make the bi bond, but there must be electron in it. If there is a p orbital and there is 1 electron in it, then they will make the bi bond. There must be a free p orbital and there must be electron to it, so that they will mix together to make the bi bond, like what happened here. This means there is 1 electron here, 1 electron here. They will share together to make the bi bond. Clear? Good. And that's so. That is if we have triple bond. If you have a triple bond like this one. Good. Now let me ask you many questions. First, what type of bond between C and H?
Single bond.
Which is called what? Sigma. What type of bond between the other C and the other H?
Sigma.
Sigma. What type of bond between carbon and carbon?
There is 2 sigma and 1 bi.
No, wrong.
1 sigma and 2 bi.
Yes. Always only 1 sigma. Always sigma is only 1. Clear? The rest are bi. 1 sigma and how many bi?
2 bi.
2 bi. What's the hybridization of the carbon? What's the electron domain for the carbon?
sp.
Sp. Everybody, is it Sp? It is sp. What's the other one?
Same.
Also sp. How are you going to make the orbitals?
Two boxes for
Two
SP.
sp and sp. And what will be left?
B.
Two boxes. What's the name of these two boxes?
B.
P and P. All right. Each one is P. Okay, that's what the first carbon. The other carbon is the same thing. sp2. No, sp. sp. And the other one is P and P. That's the other carbon. Now, this sp and this sp are this orbital and this orbital. This orbital will interact with what? Of course, each one has one electron in it. Okay.
Doctor, the fourth box is for what? Each one for what? Carbon
I'll
or
tell you
hydrogen?
now. I'll tell you, that's why. Now, look at the sp. These are the sp for the first carbon. This sp and this sp for the first carbon. And this is the sp for the other carbon and the sp for the other carbon, which is this box and this box. And we're already talking about sp. Where are the p orbitals? This is the p for the first carbon. This is the second p for the second carbon. And this is the p for this carbon, for the second carbon. And this is the other p for the other carbon. Now we want to see how the orbitals are going to interact. sp of this carbon will interact with what?
SP to the other carbon.
No, now the one I'm drawing here, this sp will interact with what?
Yes.
With hydrogen.
With hydrogen, and they will make the bond. Clear? The other sp of the carbon, this is the other sp, will interact with what?
With the SP from the other carbon.
The other carbon, and will make also the bond. So the first one is with hydrogen. This is CH bond. The second one is carbon-carbon bond. And same thing here. This is CH bond. And this one is carbon-carbon bond. So these will interact with each other. This one and this one will interact with each other to make the sigma bond. Now, how about the p orbital? This p orbital will interact with this p orbital. So this p orbital will interact with this p orbital to make what type of bond?
Bye.
I bond.
And the other p orbital will interact with the other p orbital to make what type of bond?
Also by.
The other bi bond. So we have two bi bonds and two sigma bond, and we can see, we can draw all these things in shape, in boxes, in orbitals. You should be able to do all these things. I hope this is clear.
Doctor,
Nah.
but there in the table we don't have B alone. We just have SP or SP2. How can we write this?
No, this is the hybridization. Has nothing to do with the P. This means, well, let's go back to the P. For example, if we have sp2 hybridization, what does that mean? There is one p orbital empty. Is this clear? If we have sp,
Yeah.
then how many p orbitals are empty? Are not hybridized?
One.
No. If it's sp, there is
Two.
two p orbitals free. How about if we have sp3? How many p orbital free?
6.
How many p orbital free? 0. We use them all. Is this clear? So we are going to have p free, 0 p orbital 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 free, 0 p let me take this away. If you have sp orbital, then you will have plus 2p orbital, each one is free. If you have sp2 hybridized orbital, then you'll have only 1p orbital free. If you have sp3, this means if you have sp3, no p orbital free. I hope this is clear. Right, I want to go now to, okay, how many in this shape, how many sigma bond between carbon and carbon?
One.
One. It must be one only, one sigma bond. How many bi bond?
One.
Also one. This is bi bond, which is one. How many CH sigma bond?
Four.
Four. How many CH bi bond?
There is no CH.
No, no way. The hydrogen cannot make bi bond. Good. In this molecule, how many CH sigma bond? In this shape?
Two.
Two, of course. How many C sigma bond?
One.
One. How many C bi bond?
Two.
Two. You must know this and know it very well. The last thing in chapter 9 was called the molecular orbital theory. The molecular orbital theory, and I want you to know this very well. I want you to know how to find the bond order. How to find the bond order? Bonding electrons minus anti-bonding electrons divided by 2. All right? What's the meaning of paramagnetic?
Have one orbital with only one electron.
Any orbital with one or more unpaired electron. What's the meaning of unpaired?
Just one.
Just one. That's the meaning of unpaired. Because all the electrons, if they are making a bond, they are paired like this. This is paired. And this is unpaired. If I have a box like this, how many am shape?
So
2. How many unpaired do I have in this shape?
3.
3.
3. How many electrons do I have in this shape?
2 ampere.
2 ampere. How many electrons do I have in this shape?
1 ampere.
1 ampere. You should know this and be able, if there is 1 ampere or more, this is called what? Paramagnetic. Memorize it. And if there is no unpaired electrons, they are all paired, like this one. This will be what? Diamagnetic. You must memorize the names. Very good. All right. And I told you to memorize the molecular orbital for 3 groups only. The first group is for hydrogen and helium. Hydrogen and helium. And the shape that you must memorize, sigma 1s, sigma 1s star. That's it. And then calculate how many valence electrons you have. If we have H2, for example, how many valence electron are we are going to have? in H2 molecule. What's the valence of each hydrogen?
1.
No, 1, 2.
So if we have valence of one hydrogen is 1, H2 will be what?
2.
2. Where are you going to put them to make the shape? I will make them this only. All right. What will be the bond order?
1.
1. How do you find it?
2 minus 0 divided by 2.
It's actually, yes, 2 minus 0 divided by 2, and it's 1. Okay. How about if I have H2 minus? Then what will be the shape? You must memorize this shape for hydrogen and helium only. Okay. What's the shape for H2 minus? Again, how many electrons do I have in valence if I have H2 minus?
3.
3. Where are you going to put them? Sigma 1s.
2.
What? 2.
Star 1.
Sigma 1s star. Then 1. What is the bond order?
Half.
Half, because it's 2 minus 1 divided by 2, which is 1/2. Exactly. Is this paramagnetic or diamagnetic?
Paramagnetic.
Para. Is this para or dia?
Diamagnetic.
Diamagnetic. Diamagnetic. You must know this. Is this
Doctor, why the A sigma for hydrogen is empty, which is up, which is above?
because there are no electrons to put in it. If you have two electrons, you cannot have more.
Doctor,
Yes.
we don't need to draw the orbitals, right?
No, you don't need to, unless if I give you in the exam, I give you these orbitals, for example, and ask you to fill it with electrons, you can fill it, for example.
But I mean to find the...
You don't have to draw the orbitals. If you write it like this, for me. That is for hydrogen and helium. If you have two groups, then this is the other shape that you must memorize, and memorize very well. If it's for O2 and if 2, you will have this shape. And if it is for this group, you will have this shape. What's the difference between A and B?
In the middle.
In the middle only, where?
Flipped. Sigma 2b.
The blue, the very dark blue, these two are flipped. That's the only difference. Okay, you must memorize these names: sigma 2s, sigma 2s star, sigma 2px, bi, and I usually in the exam we don't give it to you like this. We usually say just bi 2p, which means it is two boxes, but I did not write it's y or z or whatever. And so this one and this one, in the exam, I will give it to you as bi 2p. And you should know that whenever you have bi in this theory, the bi consists of how many orbitals? 2. Clear? Same thing with here. I will write bi star 2p and bi star 2p without, I'm not going to, but you know that bi 2p can take how many electrons?
4.
4. And bi star 2p can take how many electrons?
4 also.
Also 4. I wrote this here. I make it here for you summarized. This is for hydrogen, and if you have 2 atoms of hydrogen and helium only, then you should use this one. If you have Be with B, with C, and then the other one is the other elements, which is Be, B, C. If you have anything that consists of one of the elements is this one, and the other one is anything else, all of them, then you should have this order. If you have only O, F, and an E, with O, F, and an E, then you will have this order. And as you said, as you can see here, what's the difference between, I'll call this one A and B. What's the difference between A and B? Only
in the middle.
These two orbitals are different. Otherwise, they are exactly the same. Good.
NF, what should I use?
What again?
NF, the compound NF.
NF. NEF.
A,
Okay, good. If we have NEF, which one will you going to use? A or B?
B.
B.
B, exactly. B. Good. Now I want you very quickly to tell me what's the valence of NEF molecule, the total valence. Come on. So you'll use B first. How is the total valence electrons?
15.
15? Yes, it is 15.
Yes, 15.
8 plus 7, which is 15. Exactly. Okay, distribute them very quickly. What are you going to write? Sigma 2s, sigma 2s star, sigma 2p, say by 2p, sigma, by 2p star, and then sigma 2p star. How many electrons will I put? 2, 2, 2, and then how many should I put in 2p? 4, and then how many? 4 more, and then
2.
No, 1 only, because I have 1
Yeah, 1
left. Good. What's the bond order? Quickly. Quickly.
8 minus 7 over 2.
Exactly, 8 minus 7 over 2, and this is equal to what?
Half.
0.5. Is this paramagnetic or
paramagnetic?
Paramagnetic.
Doctor, I don't understand how can we get 8 and 7 for NE and F?
What's the sigma bonding without star at 2 plus 2 plus 4? What's the total?
8.
And the other one, which is the sigma, is for star. 2 plus 4 plus 1. What's the total?
5.
Okay, good. Let's do something else. Let's do N2 plus. I want you to draw the orbitals for N2 plus. Which one you're going to use? A or B?
A.
A, exactly. That's the first thing. You must use A, not B. Okay, good. N2 plus. What's the, draw the shape with me. Help me. First, what's the valence of N2 plus?
9.
What's the valence of N2 plus?
9.
9.
Yes. 5 plus 5, which is each one, and then we have to subtract 1 electron because of the plus, and the total will be 9 exactly. Now write the shape quickly. Sigma 2s, yes, sigma 2s star. You must memorize this, and then by 2p, sigma 2p, and then by 2p star, and then sigma 2p star. You must memorize this very well. Distribute the electrons. Where are you going to put them? 2, Then
2, 4, 1.
2, 4,
1.
1. Exactly. 2, 2, 4, 1. Okay, good. And then what's the bond order?
7 minus 2.
7
minus 2 over 2.
Yes, exactly. 7 minus 2 over 2, which is equal to what?
5
over 2.
2.5.
2.5.
Here, let's do one more example. I will do everything here, change simply. Instead of this one, I will, oh, by the way, is this molecule, is it paramagnetic or diamagnetic?
Paramagnetic.
Paramagnetic. Paramagnetic. Good. All right. Good. Let's do N22 minus. For example, what will be the shape, the total valence?
5 plus 5 plus 2.
Plus 2. What's the total?
11.
12.
12.
12. Okay. All right. Next. How are you going to distribute them? 2,
2,
2,
4,
and 4, and then
2,
4.
2.
2 and 2. Excellent. What's the bond order?
8 minus 4.
minus 4 over 2.
4 divided by 2 equal to what?
2.
2. My next question, is this paramagnetic or diamagnetic?
Diamagnetic.
No, not dia, it's para. Tell me why.
Why?
Empty.
200 electrons.
Yes.
The pi is how many orbitals?
6. Have 6. 4 electrons.
Rooms. The pi is 2 rooms, not 1.
Yes.
I told you. And then, since we have 2 electrons, where are you going to put the electrons? 1, 2. Now, is this paramagnetic or diamagnetic?
Para.
Paramagnetic. And so N22 minus is paramagnetic. N22 minus is paramagnetic according to this shape, and there will be, we'll put 1 electron here, 1 electron here, and that's why it is paramagnetic. All right, this is the end of the discussion today. Tomorrow, I will put, actually today for you, problems in chapters 6, 7, 8, and 9. And we will, tomorrow, inshallah, in the recitation, there will be regular class, and we will go over these recitations. Again, like last week, don't join this room, join the room in which we have 25, 26, 27, and then 31, 32, and 33 room. Is this clear, ya shabab?
Yes.
Yes.
Okay. And now I will just take the attendance as usual very quickly. Let's please go to the attendance. Do I have to make the link or I don't have to?
Can you send it, Mr. Dictor?
As usual. All right, go ahead and make attendance quickly.
Doctor,
نعم.
when the deadline of the homework of chapter 9?
أنا سويت أظن أرسلت لكم الهوم ورك ولا لا؟
إيه بس الديدلاين مو واضح متى يعني.
ليت السبت ونسيت الآن. ما كتبت لكم متى الديدلاين؟ ما كتبت لكم على الواتساب؟
لا بس أرسلت هذا في البلاك بورد.
أظن المحاضرة السابقة قلت لنا يوم الجمعة.
خلنا نشوف. كان لازم تشوف يا ما كتبت لكم. بكتب لكم اليوم ان شاء الله. اظن مخلي السبت بس والله نسيت. بس بكره اهم شيء زي ما سوينا الاسبوع الماضي حتكون محاضره مشتركه معانا ومع السكاشن 31 32 33 وكل في وقته، يعني ما في لا حد يجي في غير الوقت حقه.
وش بيكون في دكتور؟
بعد بنزل لكم في البلاك بورد اليوم مسائل بتشوفونها، مسائل problems from section من chapter 6 7 8 and 9 problems or questions، وبنناقشها بكره. شوفوها، بكتب لكم في الواتساب، شوفوا المسائل هذه ودرسوها قبل ما تجون، على اساس اذا عندكم اسئله نحلها سوا، واذا في واحد عنده سؤال على هالاسئله هذه نقدر نمر عليها.
يعطيك العافيه.
يا اهلا مرحبا، حياكم.
دكتور
نعم
عندي سؤال على chapter 7.
تفضل.